Welcome everyone to Apex Workshop Webinar 10. Tonight we're talking about exception or error handling. We're going to look at how exceptions get thrown in your code and where those error messages pop up if you don't handle them. And then we're going to explore how we can use try-catch blocks to handle exceptions a little more gracefully. And along the way, we're going to write our own error logging utility class that will capture the output from exceptions and drop those into a standard case record. And while we're doing that, we'll also get to take a look at a few other topics, such as DML versus database methods. We've only touched on database methods briefly, so we'll get to see them a little more. And as always, we will be looking at the various errors that just crop up as you are writing Apex and what those mean and how to interpret them. We'll look at how to read other people's code when you encounter it out on Stack Exchange or blogs or wherever Google takes you. And I will also take a look at interpreting the documentation for exceptions and database methods, so that you're prepared to dive into those when you want to take these concepts to the next level. So with that said, I'm going to go ahead and copy the link to the GitHub gist into the chat again, so that you can all get there and get the code we are working with tonight. And go ahead and start our screen share here. All right, here it comes.
We see it.
All right, you should be looking at the GitHub gist. And this particular gist has 4 files in it. So first one that's on my screen here is a pseudocode version of the log utility class. Above that, you'll find the detailed one that we are going to write tonight. Then below that, we have the unit test for this log utility class. And then what we need right out of the gate is this little snippet, these 4 lines of code that will help us to throw some exceptions. And this is some bad code that is useful to drop in whenever you want to force an exception. There are a couple different methods for doing that, but I thought this one was pretty straightforward. And what we're going to be working in tonight is the lead trigger that we were writing unit tests for in our last session. So this is on your screen, and if you don't have this already, you can find this also in the GitHub gist. Not in that same file, but if you go up a level, you should find a lead trigger gist in there with this exact lead trigger in there. And this lead trigger, for those who were not in the last session, is a simple trigger, honestly, something that could be done better with workflow, but we wanted to keep it simple so that we can really practice working around it. And all it does is watch for 2 different fields to change. This first block here watches for the status field to change to closed, not converted. And when that happens, it will update the rating field to cold. And the next block down here is watching the company field. And if it's changed to our competitor Inc., it will set do not call to true. And again, both of these are kind of bogus, simple examples, but they get the job done, and we're now going to work on breaking them by pushing some bad code in here that'll force some exceptions. So exceptions are just errors in the code that can't be caught by the compiler. So something that can be caught by the compiler is a missing semicolon. And if you try and save it without that, you get the error messages that the compiler tells you your code is not written accurately. But there are a lot of other things that the compiler won't notice, but that you can create and will set up a situation that the code won't be able to execute it at runtime. And there are many different types of errors, dozens of different exceptions. And error and exception can be used fairly interchangeably, although exception is the official word that you would encounter in the documentation. And with that, let's actually see what an exception looks like. So I have down here at the very bottom of my lead trigger, I dropped those 4 lines into a comment block. So let me cut out the comment pieces there. And what we've got here is first we start a list, an empty list of strings. We add 1 item to our list. We add the word word. And then next we create a string called S1. And we give that string the value of the item at index 0 from our list. That's all well and good. We know we added 1 there. But then the next thing we try and do is we create another string called S2, and we tell it that it should get the second item in our list. Well, there's only 1 item in there, so when the runtime engine executes this particular line, it'll throw a list exception telling us that there's nothing at index 1. So I'm going to go ahead and save this because as far as the compiler sees it, this is perfectly fine. But now if we go over to our UI, and which one of these is that? All right. Here it is. Okay, I'm going to go ahead and open up any old lead here, and I'll try making an edit. And since this is an after update trigger, we know that any update is going to execute that trigger, and there is our error message. So this is the familiar ugly red error message that hopefully your users never see, and that as developers we do our best to ensure that they never see. So there's a lot of added information here, but really the crucial information is what we see here: system, list exception, list index out of bounds, and it tells us exactly where it happened, trigger.leadTrigger, and the line and column on which it happened. The line is useful, column not so much. In fact, I've never even seen columns besides column 1, so it's really all about that line there. So this is how the exception messages show up in the user interface, but you can also get similar exception messages through the APIs. So if you were using the data loader to insert, or in this case, update a lead, and that bit of bad code was in there, you would get the same message returned back to the data loader. Additionally, the developer that wrote the code that is listed as the created by for that Apex trigger will get an email to their user's email address, and it will give you some details of the error message. But that's not a very reliable way to find out about your errors. It doesn't give you as much detail as you might like to really be able to troubleshoot it. And nor is it a great way to sort of keep track of how many times this error has happened, unless you want to go through and count emails in your inbox. So we're going to look at some ways that we can avoid getting the errors thrown here in the interface or through the API. as well as capturing those errors someplace useful. But going back to our code, we happen to have this here at the end of the code, but pretty much anywhere that we put it in the code, it's going to throw that same error. And regardless of whether it is at the beginning or in this case at the end, whatever this code has tried to do in the transaction and whatever other code was attempted in the transaction, including workflow field updates, process builder, everything will get rolled back. So even though it's at the end here, after our update, this update would never happen simply because this exception was the last thing to get thrown. In fact, let's see if we can demonstrate that. So taking a look at what our code is doing, we're going to have to set either status to close not converted or company to our competitor. So let's find a record where we can make that change so that it will actually drop through all of this and normally would make the correct changes. All right, so it looks like our company is already set to that, but the lead status is something we can change. So we'll go ahead and change lead status to closed not converted. And if all were well, rating would get set to cold on this, but it's not even going to let us get that far. So it throws that same error, system list exception out of bounds, and rolls everything back. And just another way to look at the same thing, if I go to a list view, and if I were to attempt to change two of these records, list view is also going to throw that. Neither record gets updated. So these kind of exceptions really just stop everything in its track and really gum up the works. So let's start taking a look at how we can cure that. All right, so what we are provided with in Salesforce and in Apex and in many other languages is some commands called try and catch. And try does exactly what you would think it does. It tries whatever code you put in the curly brackets. So actually I'm going to move this down a bit. Let's see. Let this just wrap it around what I've already got here. So I'll start my try statement before all of this bad code. And then the second half is the catch block. And this is always there to catch an exception object. And when an exception occurs in the try block, it will then allow you to execute some alternate code to handle that exception. You don't actually have to do anything here. In fact, I'm not going to put anything here. I'm just going to save this as is. Now what we know is that any exception that occurs within these 4 lines should be handled more gracefully and not throw the errors that we saw. So let's see if that happens the way we believe it's going to happen. So I'll go back into one of my records here. And first I'm just going to try any old edit, not trying to actually invoke our update. So I'll just try and take out a comma from the title. And now it goes through just fine. That try block caught the exception and obscured it from the user so that the code could continue functioning. Let's take a look at how that actually plays out in the log, because an exception still did get thrown. It just wasn't put in front of the user, and the code was able to handle it a little more gracefully. So let's see, this looks like the most recent log here. And if I scroll down somewhere near the bottom, we can see that here we have our code where we create a string, a list of strings, and then we add something to that list, and then we set up a variable s1, and then as soon as it tries to set up that second variable, that string s2, we can see it does in fact throw that exception. So the exception still did get thrown, but because it's in a try block with a catch statement, it did not stop the processing of that transaction. And to take it a step further, if we invoke our actual trigger code in there and change this to closed not converted, it will go ahead and update that to the rating to cold. So at the very most basic use of exception handling, you can use those try and catch blocks to at least prevent the errors from stopping processing that you want to happen. Now, what it's stopping is anything that happened within this, or what it is stopping is anything that happened within the try block. So here, we've only got this try catch block wrapping around this code that we actually know is an error. But in practice, you probably would have your entire trigger wrapped in a try catch block. So I'm going to move the try up to line 6 before we start into our loop and let it cover all of the loop, all of the conditions, and also cover the DML update statement we have here, as well as the bad code. And this way we know that everything is potentially covered. So I'll go ahead and save that. And now let's see what happens here in our UI when we make a change. So I'll put the comma back in the title after VP. And it is still able to handle that because the try catch was able to obscure that error. And let me find, let's see, I can go ahead and change the company here to the other string that we know invokes our code. And so with this, we expect that do not call Boolean to get marked to true. So what we've been able to do with that try catch block here is really ensure that the processing that we want to happen still does happen, and that anything that caused an exception doesn't actually impede that code. However, when we have a whole try catch block like this, it can also cause problems with where the exception occurs. So we currently have this happening after all of our desired code here, the updates, that is. But if this were actually right at the outset, and put that up there, and to satisfy OHOD, I'll go ahead and use my Control-All and then Shift-Tab to get all of my indents in place.
Thank you. I appreciate that.
So now our error we know is going to get thrown before any other processing. So let's go back over here and see the difference. So first I'll just do an edit that is innocuous. And now we can see that this did still go through. Let me find now another record that I can muck with. We'll pick on this one. And see if we can trigger the closed not converted, setting the rating to cold. So as we can see, now that that exception is getting thrown right at the outset, it actually stops processing anything below that until it gets to the catch statement. So at this point, we think, well, nothing happened. This should have gotten changed to cold. And that valuable information that an error was thrown is lost. If your salespeople were doing this, they might not know that that was supposed to get changed to cold. They just set it to closed not converted and went on to the next lead to work. And we as the developers or the system admins, we're the ones who need to be aware of that. Right now, the only place that that error is noticeable is in the log. And for that matter, it's only in the logs of the running user. So again, if this was a salesperson who was making that change, you'd only see it in their logs. And the odds are that you are not capturing logs for every transaction that all of your users are making. So this error at this point is pretty much completely lost to us. And that means that we're never going to know it's there until somebody finally catches it. And then we might have a lot of data to go back and fix, as well as just trying to figure out what's causing it, because we don't really have any clues. We might know, oh, there's a trigger on that that's supposed to do that, and that would be a clue. But once you have a lot of triggers built up, it can get really difficult to figure out where in that whole process it happened, especially if you can't replicate the error. A lot of times the errors happen due to very obscure problems, because if they had been obvious problems, hopefully you would have written your code in a way to handle them. So what we're going to look at is how we can capture that particular error message so that we'll be able to review those later on, or get notified about it immediately so that we can take action. But before we start working on our log utility, I wanted to give a chance to ask any questions about exceptions, or see if Ohad has any wisdom to impart that I have glossed over. So are there any questions or clarifications?
I will. I don't have much to add. I mean, you've done obviously a pretty good job going over it. The only thing I would kind of note here, and I have a feeling you'll probably get to it later, is that the purpose of try-catch blocks is not to hide the error from our users. That's not the purpose, right? The purpose is to handle the errors correctly and be able to take action. If we just use try-and-catch blocks to hide errors, then essentially some of our code may not work, and we may never know about it, because we just hid the exception.
And tonight's workshop would have been called Apex Error Exception Hiding instead of handling.
Yeah, so that's the only comment I have. I know you're going to get into how to properly handle, but I kind of figured I'll just say that so people understand it. That's not the purpose.
Thank you. And that's a very good point. Up till now, it just looks like, hey, I just want to hide it. Sweep it under the virtual rug. The exception we were throwing was a list exception, but there are many different types of exceptions that can get thrown. And each of them relates to different aspects of the code. As you can see here, there's a lengthy list in the documentation. Some of them probably have some obvious causes: math exception, limit exception. And then there's a lot that are pretty cryptic: no such element. Null pointer is probably one of the common yet cryptic error messages. And in fact, they even show an example here of what that might look like. In this particular sample of how to force an error, it is setting up a string called S, and it doesn't actually assign any value to that string. So there's no S equals this sentence is my string. It just goes right on to the next line where it it invokes that S, and then it tries to use the string method called to lowercase. Well, since there's no string, when you try to change it to lowercase and there's a null string, you get a null pointer exception. So these are ones that are pretty common. There's quite a few different ways that those will crop up on you. And if I keep scrolling here, you'll see that the number of possible errors is rather daunting. And then it says, and this isn't all. There are other ones. Canvas and reports and sites can all throw their own type of exceptions. But fortunately, exceptions also have a lot of ways to get information out of them. So here we start encountering the exception methods. So when an exception does get thrown, and we have properly written our try-catch blocks to handle that, we can use all of these different methods to get very detailed information about the exception that was thrown. So we have some pretty obvious ones like get line number that says exactly where it was thrown, or get message, which is the actual error message, get type name, which will pull back one of the exception types that we saw in that long list above. And probably one of the most useful ones as you get a bigger code base is the stack trace, because an exception may get thrown as a result of one trigger kicking off an update that calls another trigger that kicks off an update that calls yet a third trigger. And the stack trace helps you to see where did this particular transaction start, what did it go through to get here, and where did the error get thrown finally. Tonight, our stack trace is pretty short because we're making all of the errors happen right in our lead trigger. But it is pretty common that a stack trace will be 3, 4, 5 lines long, describing multiple classes that the data has progressed through as it goes through all of the changes in code that you have. The other ones that we have here, init, cause, and set message, are examples of exception methods that you can use when you want to create your own custom exceptions. So besides the built-in ones that Salesforce provides and lists here, you might wish to create your own particular exception. This can be useful particularly with things like Visualforce, where you want to be able to put an error either in front of the user because you want to give them some recommendation about how to proceed. In that way, it's kind of behaving like a validation rule, that it'll pop a message up somewhere on the page saying you must put in this type of data to save this record. And then the other one that I left out here is this get cause, which actually returns the entire exception. So it's sort of made up of all of these other 4 that are here. We don't tend to use this one as much because we really want to separate the information out into the component parts of our exception. Then looking a little further down the documentation, the DML and email exceptions extend the information even further about what we might want to get back. DML is certainly one of the most common actions that we are using in Apex. That's all of our inserts and updates. And so the DML exception methods give us even more detail about what happened in that particular failure. So it can tell us things like the name of the field or fields that caused the error. So that might be trying to put in a string that's too long into the first name field on a lead. It can return specific messages about the DML type, such as insert versus updates. And it can also tell you the number of records that were also in this particular transaction. So if you were uploading 1,000 records through the data loader, and only one of them actually had a first name that was too long to fit in the first name field, this is going to tell you how many other records were also in that same transaction and were also caused to fail, which brings us back around to why we bulkify our code, so that we can handle those large batches of records, but it also means that we are at risk that all of them can also fail if one of the records fails. All right, but let's get out of the documentation and back into some coding here. All right, so back here, we've still got our try block up here at the top. And as we saw when we had it up there, it just caused everything to break. But we did not know that it had broken unless we went into the logs. So let's start looking at how we could get that information out of there. So that's what our catch block is used for. So the catch block will only execute code if an exception is thrown. And at that point, we want to use this to either perhaps correct the situation if it's something we can identify and correct. But more commonly, you'll find this used to somehow capture that error so that it can be examined and ultimately resolved. And so what we're going to do tonight is we're going to build ourselves a log utility that will capture all of that information from each exception and write it to a standard case record. So at this point, you'll want to make sure that you have gone to that gist, because what we're going to do next is start building our log utilities. We're going to set aside our try-catch work for a little bit, and we're going to dive back into some Apex method writing so that we can start capturing our error messages. So I've got the entire log utility class here. If you're feeling up to the challenge, you can copy the pseudocode example and get some practice writing out these log utility methods. Or if you are in observation and auditing mode tonight, you can just follow along with the bouncing cursor. So let's look at what we've got here in our log utility. So we've got a couple different, so this is just a standard class, public class, and it's called log utility. And we've got a couple different methods. Let me go ahead and compact these down, and we'll see just those three methods that are in there. We've got the obvious one, error log, which is the method we'll use when we want to log an error. But just for convenience, we also have one called message log. And this is similar, except that it doesn't wait for an exception. We'll be able to use this anytime we want. So if we just want to make a note that a particular line of code was run, we can always use this. And it might help us to troubleshoot our code later. Or we could even use it every time a particular trigger gets run. We could have it create a case, and we would just know, hey, this particular trigger was only run once in the last 3 months. Maybe we should consider deprecating it because it's just not getting used. Or then the third one, InsertLog, I guess you might call it like a helper method, because ultimately both of these end up calling InsertLog. And why is that? That is because each of these is a little bit different. So this first one, message log, It's just creating a case with the type message. And the second one is creating a case with the type exception. And in our first one, the subject is just a custom message of our choice. So a developer note to ourselves about why we wanted to get a particular message at this point in the code. Whereas the error log is actually getting the error message from the exception that was thrown. And in fact, then it goes on into the description, and it starts packing in more details. It gets all of the affected records IDs. It gets the exception type. It gets the stack trace and the line number. So the error log gathers a lot of details we're going to need to troubleshoot this. Whereas the custom, or the message log, it's just grabbing the record IDs and then whatever custom message we wanted to pass into it. So each of these is creating cases with different data going into them. However, there's also some data that we want to use, we want to put in every case that'll be the same regardless of whether it's for an error or for a message. Well, we could just write that same information into each of these, but as Ohad said earlier, we try not to be repetitive when we are coding. And so rather than repeating the same stuff twice, we're going to put it down here in a third method. So in both of those previous methods, we want to capture the user, the running user that triggered it by using the getUserID method that'll tell us who actually caused this, this code or this error to happen. For the purposes of our class, I'm dropping that into the case reason field. I didn't want us to have to go ahead and create custom fields and custom objects and all that. I wanted to be able to just get right here into the code. So I'm using the reason pick list since it will take other values to drop in the user ID. And I'm doing the same thing with the actual class and method from which the error or message originated. And I'm putting that into the case origin field. So I want these two things to occur whether I'm creating a message or an error. And again, I could have put these right in each of the methods. And really, 2 lines of repetition, not so bad. But once you start getting into 20 and 30 lines, it's much nicer to have it all neatly in one method so that when you have to make changes to it, you only have to change it in one place. And we can see that at the end of each of the other methods, the message log and the error log, we call this third one InsertLog and pass the information that we've built up so far to there for the final processing. Now, one other difference you'll notice here is that when we go to insert our case record, we're not using the DML that we have looked at before. Previously, we had just used the insert verb to insert a case. And while we could do that here, in this particular log utility, we're going to do something a little more complex. We're going to use what's called a database method for inserting our record. And you can see that we still do have that insert verb buried in here. But what you can also see is we're invoking some options. So we can see here there's something referring to options. Well, database methods are an alternative to DML that gives us a little more power and a little more control over how that insert or update actually happens. And there was one particular option that I wanted to invoke in this particular utility class, and that is the pretty well named, allow field truncation option. What does that mean? Well, it means what it says. It allows the data to be truncated, shortened, to fit the field. So in that example I was giving earlier about trying to insert a record that has a first name value that's more than 40 characters, well, if we're using a database insert method, it's actually going to truncate the data so that it will fit in that first name field and it won't throw an exception. Now we're sort of getting a little meta here because we're talking about throwing exceptions on exceptions. And because we are trying to capture error logs here, we want to do as much as we can to make sure that we capture that error. We wouldn't want to have done very diligent coding, made sure we handled our exceptions, that we're about to write it to a case so that we can investigate it, and then have it fail to get written to that case. And in particular, because error messages and stack traces can get really lengthy, we can't really reliably predict whether it's always going to fit in a 255 character field like the case subject. So by using this option, we're guaranteeing that it will get something. It might not get everything, but it'll at least get enough and it will get written there. Let's not get too distracted by the database versus DML, because I will come back to that and we'll take a look at the documentation. But let's continue on with really examining our class here. So we've looked at the three methods, and we noted that the first two call this third one. Now let's take a look in each of these and see what's going on in each of these. So we start here with our pretty standard declaration of a method. We're keeping this pretty basic with a public static and then void because it's not returning any data, and then the name of it, message log. Then it takes quite a few arguments here. So we've got all of our arguments here in the parentheses. These are all of the data that the method must get in order to process the actions that we have written into it. So it is expecting a string that it's going to call class method, and it's going to expect another string that it's calling custom message, and then it's expecting a set of IDs that it's going to call record IDs. And bearing in mind that this particular method is just a simple message, not our exception, this one we're just using to capture some friendly information that we might want to use. And so as we pass in that custom message, we're going to make that the subject of our case. And we're also going to copy it again into the description. That way, if it's longer than the 255 characters of the subject field, we'll also have it here in the description in its full length. And we're going with a pretty standard approach here of creating a new case. We call it log entry. And we set the type field to be a value of message. But then where it does get a little trickier is here when we start to populate the description field. So we're actually trying to put in two different pieces of data into our description field. We can see here that we are going to put in our record IDs. So this first part here is just some text in single quotes, and then we're concatenating to that with that record IDs variable. That's the set of IDs that we'll be passing into this. But then we want to actually show our custom message. Well, we could just concatenate that on, but hey, let's clean it up a little bit. So let's actually put in a line break or a new line character. So this is something we haven't encountered yet. but there is a common sequence in coding that is a backslash followed by the letter N, which will force a new line into any string. So by doing this, we're breaking up that list of record IDs and the custom message onto different lines. And then after that, I can concatenate on our custom message, excuse me. So now we've sort of built the basics of our case. We haven't actually inserted the case. We've just set up a case in memory, populated a few fields. And at this point, we pass it off to that InsertLog method by saying, grab that whole case that we called log entry, but then pass this string class method right on through. So we don't actually use class method here. We're passing this argument from message log into another argument that we're passing off to the InsertLog method further down. So here we're just taking a look at how we can sort of pass data around between these methods. And when you start looking at others' code, more advanced developers, you'll see that there's a lot of this going on. So one of the other concepts that I'm introducing here with this utility is that there will often be a lot of methods doing small functions and passing that data back and forth. And it does often become a game of connect the dots. So you end up looking at, where does this go? All right, that gets passed to there. Where does that end up? Well, that ends up down here. So really getting used to seeing how these different methods connect together and pass information, do a little processing here, a little processing there, is a pattern and a knowledge that you will just gain as you do this more and more, and hopefully also writing it will help you to get used to thinking in these terms. Now let's take a look at the differences here in our error log. Relatively minor differences. So here in our error log method, we can see once again we're expecting a string and calling it class method. But now our second argument is the exception, the error message that was actually thrown in the code. And then once again, we return to getting a list of our record IDs. And then we go through a pretty similar pattern here. This time we're setting up a case again and calling it the same log entry. And this will be set as an exception type instead of message. And by doing this, if we're looking in reports or views, we start to get a little more control over if we want to filter out only the exceptions from the messages, or if we want to get a record count of how many exceptions there are. And because we set the subject to the actual error message, we might then be able to group all of our exceptions by error message so that we can see whether there are a lot of a particular message or only one, and that was sort of an anomaly, and maybe we don't need to worry about it. So that's another advantage to passing these messages into an object like cases. We're going to be able to report on them. We're going to be able to track the errors and the bugs over time and really be able to see how well our code is performing. And of course, we can also set up workflow rules so that we get an email every time one of these exception cases gets created. In my orgs, I actually use the subscribe on reports, and I just have a report sent to me each morning if there are more than 0 exceptions thrown on a day. That way, I only know about it when there are exceptions. I don't have to look every day. So putting these into cases really gives us a nice way to be able to track. And then, of course, using the case features, we might even be able to use it to help us resolve it as we work through it. Our description for the error message gets a little more complex. But again, we're just using that pattern of capturing a piece of information and then starting a new line. And then we go on and get our exception type. So whether it's a list exception or a DML exception, we'll get that here. On the next line, we get a stack trace. And then on the final line, we get the line number. So a bit more detail because we actually want to have some clues about how to fix our error. But then once again, we go here into the insert log for the final processing and pass it down where we pick up the class method and the user info, the running user that triggered it, and then finally get into our insert. So let's go ahead and actually hook this up to the catch statement now that we've taken a look at what's happening in here. So I'm going to go back over to my lead trigger. And right here in the catch statement, now I can call that log utility and see if my autocomplete picks anything up. Nope, I'll give it another poke. Here we go. There we go. Now I got the autocomplete to show me all of the methods that are there. So I think here I'm going to use my error log because this is the catch, and the catch is catching exceptions. So I'll go ahead and put this in here. As soon as I accept that autocomplete, it gives me the variable name from my error log method, which is okay. I kind of wish it would tell me that this is supposed to be a string, this is supposed to be an exception, this is supposed to be a set of IDs. Well, hopefully in a future developer console it'll get a little more sophisticated, but for now we just have to know what these are. So class method is a string that we get to declare. Now there are ways that you actually could force the code to programmatically extract lead trigger at this point. But I find it advantageous to choose my own string here. And that's because I might want to use multiple references to lead trigger. I might end up having multiple catch statements or multiple references to error log here, and I might want to have lead trigger 1 and lead trigger 2 so that I can know that there are different points in this code at which this happened and I want to catch it. Again, that just gives me a way to organize them when I'm looking at them in a report. So I'll go ahead and, since this is the only one in here, I'm just going to leave this with lead trigger. That should be enough. Conveniently, the exception that we caught is already given the variable name of E, so that's just going to get passed right into there. And then finally, we have to capture our record IDs. Now, if you recall, in our method, this was expecting a set of IDs. And the way we can get a set of IDs here in our trigger is from the trigger.new map. So if you recall, every trigger has two collections. There are the lists, trigger.new and trigger.old, and there are the maps, trigger.new map and trigger.old map. And those maps are a map of an ID to the record. So the key set is the IDs and the values are the actual records. So here I can just say trigger.newMap.keySet, close that off with a semicolon. And now I know I'm going to get a list of all of the record IDs that were potentially affected by this error. So let's see now what happens when we trigger our error. Go back over here. And let's see, I'm going to go ahead and pick on a new record here. See, that one's already closed, not converted. Let me go ahead and jump into this one. So we can see here it's open, not contacted, do not call, and rating are both blank. I'll go ahead and choose this to closed, not converted, which ideally should set the rating to cold. But we know that we have an error there. But now, because we have added in that log utility to write to a case, if I go over to my Cases tab, and let's see, let me resort that. And here we have that case that our log utility just created. And what we can see in here is varying information. Here's where we set the type field to exception, and the case reason to the user ID. We can see the subject captured that error message we were seeing in ugly red before. And then we got our added details here in the description. We got our record IDs. Got our record IDs on the first line, the exact exception type on the second line, the stack trace here on third, and then the line number itself on the fourth line. All right, so I've just done a lot of talking about this and sort of pointing and clicking, but I always like to give you guys a chance to actually get in and try doing some coding yourself here. So I'm going to give you some time now to go ahead back to your developer consoles, and you can either choose to copy that pseudocode and really try and bang out all of these methods. Or in the same GitHub gist, I also have this exact log utility with all of the code already done, and you can cut and paste that in. But what I want you to then do is find your lead trigger and add in the try-catch blocks on your own, and then call the log utility. So go ahead and give everybody a few minutes to start working on this. And as we saw last time, this is when strange errors crop up and questions really crop up. So as you are working through this, if you have those questions or errors, go ahead and drop a chat message in so that we can all explore it, because really seeing these type of errors that crop up and how to resolve them, how to understand and resolve them, is really important. That's one of the things I most want to be able to help everybody get through, so that when they're doing it at the job, you're well prepared for that. So I'll give everybody a few minutes here. I'm going to copy the GitHub gist into the chat again for anybody who joined a little late here, and we will reconvene in about 10 minutes. If you get it all done and get it working, go ahead and see if you can invoke the error, and then type done in chat so we get a sense of who's progressing on. So, all right, I'll talk to everyone here in 10 minutes, or we'll find some problems to solve. Okay, hopefully everyone got a chance to play around with the try-catch blocks and the log utilities, or at least got a chance to go up and get a drink of water and go to the bathroom. While we were working on this, Sajian came up with a question that is perfectly in line with where we're going next. Sajian asked, is there a way to achieve try, catch, and then continue in case of error? I know that in case of exception, control will go to catch block. Can we use nested try, catch? I'm not exactly sure about nested try, catch, but before we consider that, I'm going to introduce the next element that is available to us. So there's a third part to try and catch, and that is a block called finally. And finally is also uses a pair of curly braces to contain its code. And finally is code that will only execute in the circumstance that the try block caught an exception, the catch was then invoked to handle the exception, and finally is where we can put in some alternative code, not necessarily for handling the exception, but to complete our processing. So in this example, again, this is a bit of a contrived scenario, but here we could actually use this to finally go back and do that update once again. So here in the finally, I could say, even though an error was caught, in this particular case, we know that it didn't really affect our updates that we wanted to make. So I can still do that same line that I had on line 27 and let the actual goal of our code here proceed on. So here in my finally block, I've put in this. A more typical use of finally might be something that recognizes what type of data was intact and which parts of your code were not, and just works with those that were identified as still intact and capable. But now that I've put this finally in here, let's go see that it does in fact do what we wanted it to do, even though an exception was thrown. So I'll pop over to my lead again. And better find another one here. Actually, I'll go ahead and change the company name here. And we wanted our code to, when I save this, change do not call from false to true. Now, normally, and just there, our previous example, with just the try and catch, the try block saw that there was an exception, and the catch block caught that exception and wrote it to a case. And now we've added a finally block, so now it's going to go on and try and process that. So we'll go ahead and save here. Oh, wait, why didn't that work? I lost something here, so we might have to do a little troubleshooting. But let's do confirm that we did get our case after all. So yes, indeed, we did get our exception. So we did, the exception still did get thrown, and we got the record ID. Now I'm kind of curious, well, I thought that was going to work. So I'm going to go to my developer console, and we're going to do a little real-time troubleshooting with Luke. All right, so let's see, which particular log is that? It must be this one here. And I'm betting this will be down at the bottom, so I'll just scroll down to the bottom here. And let's see. I have to work my way back up a little bit here. All right, so there is the database insert. So here's where it created our case. Now let's see, that finally block on lead trigger was on line 31. So we should have gone through our catch on line 29 and 30 and then gone into our finally block. On lines 31 and 32. And it's saying map ID leads values. So let's see, I'm just not seeing what happened here. I'm going to go to my timestamp. Actually, I can go to any of the column drop-downs here. I'm going to add this column for method, which gives me a little more information. Because what I want to check is, am I still in the same method when I'm looking at line 32? Ah, Sajayan got it. Yes, that's right. So the error got thrown way at the top, and everything after was cut out. Ah, very good. All right, so let's see if we can sort of force our error in a different spot. So thank you, Satyan, for catching what I didn't catch. So when our exception got thrown here on line 9, everything after that stopped dead in its tracks. So that means we never went through all of these for loops and down here to the populate this leads to update. So let me go ahead and actually force the exception somewhere else in this code. All right, so I'm going to put it here at the end of the code after our update statement. And just to sort of make sure that what we're seeing is a real result, I'm actually going to comment out the finally block, because we want to see that just like this, without that finally, this update doesn't happen, that the whole transaction gets rolled back. All right, so let's go over to our lead window here. And I'll find yet another lead. Oh, that's my cases. So let's go to our leads list here. Find one that we have not edited yet. And we'll set this to close not converted. And it did go ahead and process through to that. And here on our cases, it did in fact throw that particular case, or did create the error that we wanted there. I may not have set up a very good example here. I may not be able to show off how the finally block happened, because in this case it did get through this line, and then the exception happened, but it caught the exception, so it was still able to process that. So I'm going to have to apologize that I didn't set up a good scenario here to demonstrate how finally can be used. I guess perhaps an alternative would be, well, I guess we could use our log utility message log. Let's see, what is Sajan is suggesting you can put the code before the update statement. All right, that sounds like a good way to demonstrate that. All right, so let's put it there so that it fails before the update, and then we can do our finally update. Let's make sure that we do have a proper failure here so that we can then have a glorious resolution with our finally statement. All right, so go to our second bit of trigger here. Change company, in which case we would expect do not call to get set to true. All right, there we go. Sajian again for the win. All right, so now we can see that in this particular case, do not call did not get checked. That's because the exception was thrown before we got to the original update. And we'll go ahead and set this back to whatever it was before. So we'll be able to do that one more time. And now let's put this same string here in our finally block. So now what we expect to happen is that it'll go through, it'll get to this bit of code here, throw the exception, not proceed on to this block. It'll go, because an exception was thrown, it'll go into the catch statement. It's going to create a case with the exception, and then it's going to go into the finally block here. All right, so we'll try this again. And see, did I save that? I want to make sure I save that before we demonstrate this. Yes, no asterisks up there in the tab. This is saved. The finally is ready to go. All right. There we go. So this time it did hit that finally block. But of course, it still did create a case showing us that error log. So I think this was an unintentional but a good demonstration of where the error gets thrown is particularly relevant to what does or does not get processed. By using a catch and exception, we allow the transaction to proceed on up to the point at which the exception was thrown. So when we had this list exception at the very top of our trigger here, nothing beyond that got processed. It immediately stopped reading further lines in the trigger, went down to the catch block, called the log utility to create a case, and then proceeded to do that to create that case. When we had this exception at the very end of our trigger before the catch block, it actually did get all the way through all of that, processed the update, then threw the exception, and still allowed the update to proceed, but did write the case. And in the third attempt, we put the exception right before the update. And when we did that, it was able to process everything up to that point. Then it threw the exception. But at that point, it exited out of the code there and skipped right to the catch block. So it never executed this update on line 28. Although we then added the same thing into the finally block, and at that point it was able to go back and to actually execute that update that we wanted to do. So one thing that you end up considering then is where to put your try and catch blocks. A simple thing to do is to wrap all of your code in the try block. That way, anything that happens anywhere in there is going to get caught and handled. Practically speaking, there are some types of things you don't really need to have in your try block. In fact, if you look here, I left line 2 out of the try block. That's because I'm declaring something that just really is not prone to throwing an exception. I'm not doing anything referential here. I'm not working with any pre-existing variables. I'm just defining some data in the first place. So something like this doesn't necessarily need to be in a try block. Similarly, I could have done the same thing with the list of strings that I set up. But then is where it starts to get has a little more potential for something going wrong. This add method probably pretty safe. I'm not going to be able to add some data type that's not suitable. The compiler won't let me. If I try and do something that's not actually a string there, the compiler is going to throw an error and tell me that this word is not declared, it's not a string. And then where things really start to get a little dicier is when I start making references to the indexes within there. And of course, where it goes off the rails is when I make a reference to an index that doesn't exist. So practically speaking, you can start your try block where you really start to process some previously created data or variables. All right, so all along we've been working with a list exception. And in our catch block, instead of actually trying to catch a list exception, we just let it catch a general exception. But one of the things you can do, and that you're likely to encounter when you are looking at others' code, is you'll see that there end up being multiple catch blocks. And that's because each catch block can be set for different types of exceptions. So I could specifically have one that's set to catch list exceptions. And then I could add in another one here to catch Arch, to catch math exceptions. Not that we have any math going on in here, but I certainly could have a catch scenario for that. And so on. I could go on and catch DML exceptions. And then what you'll probably see if you encounter this is the final catch block would again repeat that catch-all exception, which is just the exception. And the reason you might do this is because you want to handle different types of exceptions differently. Now, for most of the code I've written, I've really just relied on using this general exception behavior and letting it catch anyone. I haven't tended to do a lot of handling that does anything other than write it to an object so that I'll be able to keep track of the errors. But if you have something that you have to make much more robust and capable of handling a lot of different types of exceptions, this gives you that granularity to handle each different one in a different way. And you're very likely to encounter that as you look at other applications that are out there and see what other developers have done. All right, so the final thing that I want to get to here is actually looking at how we test this kind of exception and utility class. So this kind of harkens back to that conversation we had before the session got started when we were warming up about when you have a utility class like the log utility, do you test it specifically, or would you just allow your lead trigger tests to be sufficient to check your utility class? So other types of utility classes might end up being something that are more easily tested within the tests with a lead trigger. You might have utility classes that handle some common functions like changing a list of IDs to a string. And that's something that you might need in your code, and you probably are going to write a test in that for the code, for the class or the trigger that sort of describes that behavior. However, in this particular case with errors, you don't really want to have to force an error in the unit test class for every trigger that you write. So I think particularly for a logging utility for exception handling, it's best to just write a test very specific to that log utility. So let me flip over here to our test class. And you'll also find this in the GitHub gist, along with the log utility. So this is a test class that is somewhat dissimilar to the ones that we have worked with so far. So far, all of our test classes have tested trigger behavior. So we would end up writing a unit test that creates some data and then perhaps updates it in a way that we would expect our trigger to behave. So for that lead trigger we were just looking at, when we wrote our unit tests, we created some leads, and then we updated the status field to closed not converted, and we used a system assert to make sure that the rating field had gotten changed to cold. And we were relying on the trigger to actually fire when we made that update in our unit test to actually cause that test action that we wanted to check. But our log utility on its own isn't tied to a trigger until we actually invoke it in a trigger like our lead trigger. But if you have never actually called it, if you're just installing it in your org in the first place and you have nothing that references it, in that case, nothing would ever test it, and you'd have an uncovered a utility class without any code coverage. So how do we go about testing something that is not called by a trigger? Well, we're pretty able to just call it directly. So that is what we end up doing here buried in our test. We're actually just doing the same thing we did in our trigger. We're just calling that log utility and passing it the data that it expects. So let's step through this utility class test and see just how we got to that point where we could do that. So since we have two different types of methods in our log utility, the message, log message, and the error log, we're going to want to have test methods for each of those. Go ahead and collapse these here, and you can see that that's in fact what we do have. We've got two different test methods here. But then we also wanted to kind of make our lives a little simpler. We know that in both of those cases, we're going to need a string that we're going to use for our class method. So I just created a string here before either of those that I'll be able to use in both of them. And I did the same thing with the custom message that we use in our message log method. So doing this in unit tests is sort of a nice way to create something that is consistent that you'll both be able to pass in to your test and then verify that on the after the method has run that it does produce the exact equivalent message, rather than actually hard coding this in twice. Let's see how that plays out here in our first unit test method. And we'll be coming back to line 4 shortly. So put a pin in that, and we'll revisit exactly what that piece of code is talking about. So here in our log message test, this is simply testing that message log. This is the one that doesn't actually handle an exception, but just allows us to pass a custom message into our case. So we start by wrapping that in the test.start test and test.stop test. And Ohad had pointed out in our last session that these are two commands you can use to put the actual action you want into its own governor limit space. Are they necessary? Not absolutely, but certainly a good practice to use, because not only do they give you that extra governor limit allowance besides the actual creation of the data that you're setting up, it's also just a nice way to see, oh, this is what is actually getting tested. Everything before this is just setting up whatever data I might need for the test. Everything after it is just checking the results. So it's you could, of course, just drop those in comments, but hey, why not take advantage of these and get some governor limit control on that? So then here, we're just calling our message log method, and then we're using the string variable test class method to just pass in that string. And in this case, it's testclass.testMethod. The second argument was also a string, and we're using, again, that variable that we defined on line 7 that is a string that says, test this custom message. Now, where it gets a little bit awkward is, since we aren't using this in a trigger, we don't really have any IDs to pass in. I suppose I could create a lead in my test data and get the ID from that lead and pass that in here. That would certainly be I think, a more complete test. And in fact, when I was building this demonstration, I was using a variation on the code that some of my colleague developers here had written. And as I started to do this, I was about to correct that and say, oh, here's the best practice. Here's how it should be done according to Luke. But I thought, you know what, I'm going to leave some of these less than ideal, less than complete coding examples in here, because this is exactly what you encounter when you start looking at other people's code, things that you would not have done. And so in this case, this developer chose to just skip over passing IDs, and they just decided, I'm going to pass null instead of passing it any IDs. All right, well, it's certainly an interesting example that you don't always have to pass every argument exactly what it's expecting. You can pass it, in this case, an empty set. And when I saw this, I put a note in myself, maybe I should go back and clean up the log utility here at my company to be a little more detailed. But so far, it's been working pretty stably, so maybe I'll just leave it the way it is. Anyway, so now we've called that message log. We passed it a couple strings, but we've passed it no IDs. Now, when it goes off to this, we would expect that it's going to create a case, and it's going to populate certain fields on that case with these two strings we passed it. So if we want to check that, we actually need to go ahead and do a query and get those records from the test space in the database. So here I'm able to make use of the variable name that I defined on line 6 to say, go get all the cases that in which I expected the origin field to be set to that test class method. So simply by doing this in the where clause using the where filter, I'm automatically kind of doing a test right in here. If it didn't actually write a case and populate the origin field with that particular string, I'm not going to get any results back from this query. I could have just done select all cases and no filter at all, and then check and see if origin did in fact get populated with that string. But this is sort of a shortcut to getting that same effect. And then if I want to verify whether anything came back, I go on to a system assert equals. And in fact, here I'm using assert not equals. I expect it to be more than 0. So I'm comparing that, saying that I expect, well, I don't expect it to be 0. In fact, I expect the size of that result set to be anything but 0. And that's why this is the assert not equals. And again, And when I looked at this, I said, this developer chose a very curious way to do this, because then, after they got that result set back, then they loop through it and they check that the subject is equal to the other string that we put in there. So I thought, well, why didn't we just put the subject test in here and make this, and subject equals test log method, or test log message. So I think it might even have been Sajian who brought this up last week. Are there different ways to do this? Can we do these kind of tests in our query instead of going through and doing system asserts? Yes, you absolutely can. There are a lot of different ways to get to the same result, and this one kind of mixes two different techniques to do that. But ultimately, it ends up checking all of the same things, that the two strings that we passed into message log did end up where we expected them to, in the origin field and in the subject field. So this was the easy one. This was the one that was just passing strings around. The trickier one is where we need to actually have an exception. And this is where when you're writing a unit test for a log utility for exceptions, you have to use something that Salesforce provides where we can create our own exceptions. So that's what line 4 is doing here. Line 4 is giving us a way to invent an exception on the fly. And it's a rather peculiar type of class, the exception class. You create a normal process of just saying public class, but then the name of that class has to end in exception. In this case, I used my, but I could use other things. I could have used test exception, but it always has to end in exception. And then you have to use this keyword extends, and once again repeat exception. That's what tells Apex that this particular class is going to be used as a custom exception. And that's all I actually need to set up here, just to give myself that ability to make up an exception on the fly. So how do we end up doing that? Now let me change this back to my, because I can already see an angry red arrow telling me that my exception no longer exists. So go ahead and fix that. Because here in our next test method, the first thing we do is we set ourselves up with our own custom exception. So here, this is kind of like creating a string or an integer. In this case, the data type is exception. And then I have to give it a name. So I'm giving this exception the name test exception. And then I'm saying this is going to be a new instance of a my exception data type. And that exists only because I called it that on line 4. And then I just pass it a string. So this particular exception would have an error message that says, test this custom message. So I've just created my own variation. Just like we have list exceptions and DML exceptions, I've now invented one called my exception with its own special message. So now when I want to go ahead and actually run my test, once again I use the test start test to kick it off, and call log utility, and call error log. And error log expects a string, then an exception, and then once again a set of IDs, or in this case passing it null. And that's okay because we're really concerned about getting the exception in that string. So then when we do this, we expect that error log is going to create a case, and that it's going to put a string in as the origin, So once again, here in our select, I'm using that as a filter. And then the other thing that I expect is that it's going to create this of a type exception, since that's the other command or the other field that we populate in the error logs. So this is a tighter version of the filter because we're filtering on two things. I could also filter on the actual exception message that comes out. But for brevity, I just decided to skip right on to the assert not equals and just make sure that something got created here. Because what we really wanted to see in this particular test method is how you force that custom exception so that you can actually have something to pass into that error log. All right. Let's see, we're just about out of time here, so I'm going to open it up for any questions or if anyone came up with any interesting errors as you were working on the lead trigger and the try-catch blocks. I'd love to explore them and see what came up and how we could resolve it. And certainly if Ohad has any wisdom to pass along or corrections to make to my misinformation, I would welcome that too.
No, I actually, first of all, I want to apologize. I was kind of in and out through the session today. And Sajan, thank you for helping cover me earlier. But I did want to answer Sajan's question earlier, actually. And Sajan asked if we can use nested try catches. So the short answer is yes, you can absolutely use nested try catches. So in other words, you can start the try block and have another try catch in that. And there's definitely scenarios where you would want to do something like this. But I will just kind of repeat what I said earlier. It's a good practice to have error handling and to have try catch blocks. And there's definitely scenarios where you want to have a large segment of code inside a try-catch block. But in general, you don't want your entire code to be inside a try-catch. When you write code, you're trying to write code that will work most of the time. If you kind of expect your entire code to fail at some point, then you're doing something wrong. But there are definitely times where you want to use a try-catch, and the purpose really is to handle a specific error that can happen. If you're just creating a try-catch to try and catch every possible error, well then it's perfect if you use something like this error logging, but at the same time you have to make sure you're not just hiding errors, which is kind of what we did in the beginning of the session, right? So yes, you can use nested try-catch. There's definitely use cases that we can that it makes sense to do that, and if we had more time, I would even maybe cover a couple. I noticed I Googled and tried to find some details around that when you posted the question, and I noticed that there isn't really any content online around this with specifically to Apex, but I did find some other .NET discussion around nested try-catch blocks that I think are just as valid as a concept or as kind of a best practice approach on what you should or should not do. So I may make that into a blog post in the near future, but in the meantime, if you really want to read more about it, you just Google nested try-catch, and there's a lot of discussion around it and a lot of good points when you should or shouldn't use something like that.
Yeah, and that reminded me, like, this is some code that I wrote a long time ago. Let me pull this onto the screen here, where I actually did use nested try-catch statements. And I actually designed it here. We can see here's a try-catch block, and then within it, there's another try-catch block. And this particular code was being used to convert or to interpret zip codes into time zones. and so I had knew that I was going to have to work through first the 3-digit zip code prefix and then move into the 5-digit. So I actually was sort of leveraging try-catch in a way to where I would expect an error in certain situations, and then I wanted to go to an alternative solution. So I'd forgotten that I did this before, but this is an example where you can use them advantageously.
Absolutely, and try catch again. The nesting can happen. You can have a second try inside the catch, or you can have a second try and catch inside the try block as well. So, you absolutely have freedom. And while Luke was kept going past that question, I actually did a little test, and it there's absolutely no reason Apex accepts it, and it seems to work. So. Yes, it can be done. And the only one other thing I wanted to bring up, and you talked about creating your own custom exceptions. You didn't really talk about throwing exceptions.
Right.
So I'll touch on this very, very briefly. I know we're past our time. We also have the ability. There's a command called throw, which allows you to actually cause an exception to fire. So you can either throw a custom type of exception like we just created, my exception, or we can throw a list exception or any kind of exception and give a message. And again, you can review that Google and see how that happens in Apex, or we can maybe touch on that in the next session. One of the places where I use throw exceptions very, very commonly is when I want to create a validation rule that is more complicated or more complex rather than what standard validation rules do. So for example, if I want to say you can only move this opportunity from stage 4 to stage 5 if you have at least 3 contacts, then really, today you wouldn't be able to do this with a validation rule because contacts is not a master detail to opportunity, so you cannot use roll-up summary fields. But you can create a trigger on opportunity that once you change the status or the stage, you can perform a little query. You can check whatever you need to check, and if it doesn't meet your criteria, you can throw an exception, and the user will get an error that can look like a validation rule. So you can use the add error message, or you can use throw exception. It really depends on kind of what you're trying to do. But again, very much related to the conversation we had today that I thought was worth bringing up.
Absolutely. Absolutely. All right, everybody. Thank you for attending tonight. And thank you, Sajian, for your excellent contributions as always. And we will meet here again in 2 weeks. I think we'll probably be looking at custom settings and feature toggles. And then after that, we'll have one more before the holidays. I think we'll be getting a some guest teacher. Bill Martinez has volunteered to create some Visual Force. So we'll finally get to look at Visual Force and Apex controllers. So that's a preview of what's to come. And I will see everybody in 2 weeks. Thanks, and good night, everyone.